Just wanted to do a slightly more technical variant of what I did with the meter in the previous video. I've calculated the time constants on these two capacitors. It should take 5 seconds to hit the first 63%, 5.67 volts. That seems to work. That seems to match up well. But watch what happens if we wait for it to reach the full supply voltage. How long does that take? Go ahead and plug in and start the stopwatch. There's our first time constant, right on cue. Still charging. Still charging, 9.1 volts supply voltage. So where does it get close enough to the supply voltage that it slows down significantly? Let's say about here. About 36 seconds. About 30 seconds. Okay, here we go. Capacitor number 2 has a little bit of a head start. That will be okay, I am sure. There's our first time constant. Good there. That really seems like it has slowed down, even stopped. Look at it. The charge is going down now. That's our 35-ish seconds where the other one had reached full charge, or close enough to full charge. This one's bouncing around almost a volt below the supply voltage. So there is definitely something wrong with this capacitor. And actually I just let it sit here about 2.5 minutes while I was reviewing the footage. It hasn't really gone up significantly anymore. This is a full charge on this capacitor, or so it would seem. But here's the trick. This thing is leaking DC. I'm now measuring across the resistor. There is current still flowing in this circuit, 18 whole microamps of current, so it is leaking DC. The same test with the new capacitor. I had to switch down to the millivolts range, and it's still drifting down even from when I calculated it. But now we're getting 319 nanoamps of leakage compared to the 18 microamps after sitting here for about 2 minutes. I figured I'd leave these running for a really long time, see what happened. And what happened is this. It got down to about 0.7 volts across the resistor, works out to about 15 microamps leakage, and then it just stopped. It never got any lower. I think there's always going to be a little bit of DC leakage in a capacitor, just as a maintenance charge. You know, if you have a capacitor that's charged and you disconnect it, it's going to very slowly discharge on its own. So if you want it to stay fully charged, you need some leakage, some current flowing into it to maintain that. And on the newer capacitor, that seemed to be about 100 nanoamps compared to the 15 microamps on this one. So it is leaking. It's not leaking a lot, but it is leaking, and the test with the multimeter in ohms range was able to determine that something was wrong with it, even if I wasn't able to tell specifically what was wrong with it like I am here.